introduction in here. My name is Yanjing Abram, and I have been teaching weekend courses since very, very beginning, since when they have the weekend course probably 10 years ago, something like that, probably a little bit more than 10 years ago. It used to be an in-person, in a Trinity campus, but they have been switching to the, online for a few years now, okay, since COVID. And then after that, they started in-person one, but didn't really a lot of people attend, so they moved to like the online version that way, so a little bit more convenient. So sometimes people probably did not realize that they actually have to attend the online one, um, for this course. Okay, I will send out another announcement later on, let people know it is a requirement to attend the online course. This is called synchronized online course for the meeting. Okay, and I teach all kinds of different courses. Of course, I teach statistics, developmental math, college algebra, all the way to calculus. Trig, pre-cal, and somewhere in between. All right. Um, but I know like a weekend course, a lot of people also work, right? And when you work, you probably have less time to complete the course. So weekend will be a very significant time. If you don't do that every day, that means you're gonna have to spend most of the weekend to do the math, right? And I usually say, if you taking one math course, is kind of equally to take two other courses. That is a little bit the amount of the content that you have in math. All right. And I will show you how to get started. We're gonna go through the syllabus a little bit, and then where to find the course. I found that several people already started the assignment, which is good. All right. So before I do that, let's go ahead and introduce yourself a little bit, if you could. You can please unmute yourself and then just tell them your name and how many courses you're taking and what's your major. And since you are taking the weekend courses, so any other job you're doing or you are not working, that's fine. If you want to go ahead, introduce yourself a little bit. All right, so who want to start? There's Mackenzie. Can you go ahead, start, introduce yourself a little bit? Just tell your name and how many courses you're taking and what's your major. Something like that, very quick. Oh, practic. Do you want to introduce yourself a little bit? Or maybe you don't have you need to unmute yourself to talk. All right. If not, I'm going to share my screen and I'll show you the syllabus a little bit, okay? Screen. Okay, so one thing is we're gonna go to look at the syllabus. I'm assuming everyone can log into Canvas, right? If you log into Canvas, you will see the syllabus and you click this link. That is your syllabus in here. Okay, let me see if someone trying to come in. All right, so the syllabus here, the most important one is the gradient, right? And you can see the grading here, the homework and review gonna count 30%. Okay. Let's see. Okay. Just trying to see. All right, homework and review, homework and chapter review. 30% we drop one of the lowest score at the end of the semester. Quizzes is also online, is 18%. And then the test here is I think we have a 4 test. Okay, so 4 tests, each test is 13%. 4 tests will be 52, right? And test 1 will include chapter 1 and 2. The Yeah, and chapter 2, test 2 include a little bit chapter 3. So that is 4 tests in here. All right, and the weekly assignment, usually I will post a little bit on the announcement as well. Okay. All right, so the week 1 and 2 we have algebra review, and then well, actually this actually I think that one is a little bit different. The test 1 is include only chapter 1. Okay, so test 1 is only chapter 1. I will fix the other one right here. This is the correct one. All right. The test 1 will include chapter 1. Chapter 1 we have a 1.1, 2, 4, 5, and 7. Okay. And chapter 2, which is a little bit more, we have 2.1 to 2.7. So that is test 2. And then basically test 3 will be chapter 3. All right. And then the final exam actually is the last unit test. So the final exam is only chapter 4 and 5. So basically, we are not going back to the chapter 1, 2, 3 for the final. Okay, so your final is only chapter 4 and 5. Well, chapter 5 is only one section, basically. All right, so most of them just chapter 4. And that is your final. Okay. Any question about the, anyone has any question about the test? Okay, and I also have an optional midterm in here. Okay, so optional midterm actually will include test 1 and 2. So it will include chapter 1 and 2. And again, this is optional. You don't have to do that. But if you do the optional midterm, and the grade is higher, it can replace one of your lowest test score for either test 1 or 2. Okay, so it is a bonus to do the optional midterm. We do not have any other actual credit, but I would just say this one is you another chance to improve your grade if you do the optional midterm. But some people say, how about if I test lower? Well, if you test lower, it won't hurt you. So it just won't replace any test. All right. So I will encourage everyone to do the optional midterm in here. Okay. So that is the grading. All right. Anyone has any questions? And also, if you have any question, I will encourage you to do the inbox message. Okay, once the semester starts, instead of sending me the email, you just log into Canvas and then using the inbox in here. The good news with the inbox is it will indicate which course section you have. All right, so I teach different courses. If you send me the email, I do not know automatically which course, which section you have. But if you send the inbox in here, it will automatically show you section and the course number. So it will be a little bit more convenience in here. All right. Okay, so assuming you all can log into Canvas, and where's the assignment? All the assignment here is under the course material, okay? And the course material here, you can launch the course, okay? You can go to launch the course, and it will take you to the Pearson website. And after that, you will open the Mind Lab and Mastering. I think before you open that, if you never have a Pearson account, you might have to register one. Okay, so it will take you there. Otherwise, you can just open that after you register that. All right, we are open that, and I will build a student's home so I can see the same as you can see. All right. And the default, usually the current one is only showing a huge assignment, right? The default usually is only 2 weeks. So I will encourage you hit the entire course today. Okay, you hit the entire course today, and then you scroll it down, you will be able to see the entire semester's assignment. Okay, that's all in here. All right. And there's a little bit quiz. Okay, the quiz here, if you trying to open the quiz, it will ask you to enter the password. So let me type on the chat section. The password here is spring. Okay, the password here. Let's see. Okay, password for quiz is spring 2026. All right. The first one is cap. Spring 2026 is one word. There's no space in between. Okay. So that is the quiz password. For the test, you do need to have a lockdown browser. Okay. That is for the test. So if you want to open the test here, it will ask you to use the lockdown browser. The quiz, you don't need a lockdown browser. Plus, the quiz, you have 3 attempts. The test will be only just 1 attempt. All right. But I have this sample lockdown browser, which you can open multiple times. Okay. Look at this, you have 99 attempts. So before you open the test, actually before the course, since course is already began, and I would say go ahead, test your browser, trying to see if you ready for the test later on, right? So don't wait until the test day and then trying to using the sample lockdown. So this one, you will have a lot of attempts. So trying to use this one as early as possible, trying to see if your browser, everything is ready, all right? And this one, it doesn't hurt you, so you can just, open as many times, 99 tries in here, okay? Otherwise, the assignment will be all in here. All right. So if you open the section 1, now you have a this assignment in here. Okay. And I think I probably also giving you a little bit video, but the video won't count as a grade. Okay, let me see if it doesn't have a video here. Oh yeah, the video for chapter 1. All right. So this one, the video for the chapter 1, you can see all the section video in here. Okay. I will also giving you a little bit summary for each section, but if you want to watch the detailed video, it's all in here, and include also the section PowerPoint. Okay, so you have a section PowerPoint in here and a section video. You don't really, if you don't want the math talk, you can skip that section, the math talk, but I just want to leave it there, for some people want to look at it. All right, so, but the video here is, is for you for the reference. Okay, you don't have to watch all the video at once. you can just watch one section video, like I say, section 1 video, and then you go to do the section 1 homework. Okay. If you watch the video first and then do the homework, that will be easier. All right. So everything is housed inside the Pearson MindNet Math. Okay. So I'm going to open the first PowerPoint here. All right. And then you can download the PowerPoint. Basically, you can download, look at that. You can download all the PowerPoint here. All right. So that is kind of a little bit a short version for the course. Okay. So I can download all the PowerPoint. Okay, so we're gonna go ahead and look at all these PowerPoint today. All right, so that will be kind of equivalent to your course video that way. Okay, so we're gonna get all the section, and then next course, next week, we're gonna have a test review. All right, so hopefully that will get you ready for the chapter 1. Okay, you can do your own download if you want, so that will give you a little bit more summary for the section in here. All right, so let's see, where do I download? I think I download in okay, I think I have a download here earlier. And let's see which section we have for this chapter, okay? Because we don't usually require every section for the chapter. All right, so let's see. If you go to do the homework, you will see the assignment. All right, just look at the assignment and then you can see which section. So we do require the section 1, and so we have a section 1, 2, we skip the section 3. You can see we don't have a 1.3, right? So we have a 1.1, 1.2, 1.4, 5, and 7. So basically for this one right here, we skip the 1.3 and 1.6. Okay. All right, let me open it. All right, so let's see this. So 3 is skip. Okay, I'm going to make a mark in here. So we skip the section 3. We also skip the section 6. All right. So we don't have every section for the chapter, basically. All right. So we skip this one, right? We skip the section 1, 3, and 6, and then we require the 1, 2, 4, 5, 6, and 7. Okay. All right. So let's look at what is on section 1. Okay, so the section 1 here, basically the first chapter is the equation and inequality. All right, so we want to graph and graphing inequality in here. Okay, so how do you plot the points in a rectangular coordinate system? Sometimes we call it Cartesian system, right? And then you need to be able to graph determine the intercept. Okay, so we have an x and y intercept like that. All right. So basically, if you this rectangular system here, you have a top right corner here. This is called a quadrant 1. Okay, so that's Q1. And then going to the counter crosswise. So this is Q2, Q3, Q4. Okay, it's not going to crosswise, it's going to counter crosswise in here. All right, and then X and Y intersection is called the origin. Okay, when you have an origin here, you're gonna have a 0, 0. All right, let me see. I can draw this one right here. All right, so we have this point right here is called 0, 0. Okay, and then the fourth quadrant, both the X. So when you have a point, right? when you have a point, you always write down x and y. Okay, x first, y second. So in the fourth quadrant, both x and y are positive. All right, so this is positive, this is negative. All right, and then on the top of the y is positive, the bottom of the y here is negative. So when you get to the second quadrant, right, you still have x first, y second, right? And then the x here is on the left-hand side of the y-axis, so your x is going to be negative, your y is going to be positive in here, okay? And the third quadrant right here, both x and y are negative, all right? And in the fourth quadrant, number 4, right? And then the x will be positive, y will be negative. All right, so those are the basic orientation for the graphing. All right, so look at this one right here. This x is positive and then y is positive on the top. On the right, for the x is positive. Left, x is negative. Down, y is negative. All right, so if I want to plug 1 and 2, so that means x equal to 1, right? Y equal to 2. So that should be in the fourth quadrant because both positive. All right. And then this one, you have a point negative 2 and 4. So x is negative, right? So you go into the negative x. And then going up for 4 units. So that is in second quadrant. We call this is Q2. Or second quadrant, right? This is the fourth quadrant, Q3, Q4 right here. Okay. All right, so that is how you plug. And then if you have 2 points right here, like I said, if I have 1 point on x-axis, so this point will be 2 and 0, right? And then I just connect these 2 points together and now become a line. Okay? Something like that. All right. Okay, so now this point is 4 and negative 2. So 4, you have x from origin, from 0, right? And then 1, 2, 3, 4, and then going down for 2 units. So that is in fourth quadrant, right? X is positive, y is negative. So that's in Q4, okay? All right, so now you can graph a line, right? You can put everything in here. You can graph a line. Okay, so how do you graph a line? Well, you will require 2 points to graph a line. Okay, so 2 points to make a line in here, a straight line. If it's not a straight line, you need more points. Okay, so let's see if I want to graph y equal to x minus 2, right? If I want to graph y equal to x minus 2, so we need 2 points. We usually set up a little bit table, x and y. And then I can make x equal to 0 and then calculate the y, right? So when x is 0, you plug x equal to 0 in and y will be just negative 2, okay? And so this is the point here, the point x and y, right? So this will be 0 and negative 2, 0 and negative 2. 0, x is 0, y is negative 2. So right here. So this is on the y-axis. So we call this point actually is called y-intercept. All right. And how do I find the x-intercept? I make the other one is 0, make y equal to 0. Okay, 0 equal to x minus 2. And then we solve for x plus 2 on both sides, right? So x will be equal to 2. All right, so this point here will be 2 and 0. Okay, so x is 2. Okay, so that's 1, 2. All right, 1 and 2. Okay, and then this point will be 2 and 0. So this point is called the x-intercept because y is 0. And we just connect these 2 points together and it's a straight line already. Okay, the good news is we do allow you to use a calculator, TI-83 or 84 calculator to do the graphing. So I'll show you how to make a graph in a calculator. Okay, if you haven't done this before, it's actually very straightforward, very easy actually to do the graphing in a TI calculator. Okay, so if I just go to y equal to, all right, and then I just type x minus 2, right? X minus 2, and then hit enter, and then hit graph. Now I have this graph, okay? And if I don't like this graph, I can zoom to standard, okay? I can zoom to number 6. I can zoom to standard, and then this look a little bit prettier, all right? And then if you go to the second graph, it will be showing you the table, right? So if you don't really want to calculate this one by hand, you can calculate from the table. You can just pretty much when x equal to, look at when x equal to 0, y will be negative 2, right? And you can move up and down, and then you can have a different x and y value, okay? And then when y is 0, x will be 2. So now you can see, yeah, this one, it passes this x 2, y is 0, right? And then this one right here, x is 0, y is negative 2. Okay, so those are the graph, and you can make a different graph. All right, that's a straight one. And if I have y equal to x squared, so x squared, this is quadratic, right? Y equal to x squared will be a quadratic, and it's facing up. So now you have this quadratic. And if you want to look at the x and y value, you can go to second table. Okay, and then you have a same x value, but you have a y2 is different, right? So when x is equal to 0 right here, y is 0 for the y2. When x is equal to 1, 1 square is also 1. All right, so that is this one right here. Okay, otherwise you can just calculate. Okay, you can calculate in here. And look at this one right here. This one, I have a y equal to 4 minus x squared, right? So we can make a table, we can make a table in here. Look at that. We can make a table x and y, right? We can calculate when x is 0, right? And then you can put it in here. When x is 0, y will be 4 minus 0 squared, which is 0. So y will be equal to 4, right? And then when x equal to 1, this will be 4 minus 1 squared. 1 squared is still 1, so that will be 3. So when x equal to 1, y will be 3, right? And when x equal to negative 1, 4 minus negative 1 square, but we know negative 1 square is positive 1. So that is still equal to 3, right? So when x equal to negative 1, y is also 3. And then we can just plug all these points in the graph, right? 0 and then 4. And then when x equal to 1, this will be 3 right here. Negative 1, this is also 3. And then just connect all these points together. Okay, so that's how you make a graph by hand. You can also make a graph in a calculator. Okay, so we have this one, 4 minus x squared, right? We can do the y3 for that one. Okay, so now we can see this y3 is a parabola upside down because the coefficient of the x squared is negative. So this whole thing facing down and then move up for 4 units in here compared to the red one. All right, so that is how we make a graph. In here, any questions? I want to see if anyone has any questions. If you have any question, you can raise your hand or you can unmute yourself and talk. Okay, I don't mind you ask question anytime at all. All right, so another one here is how do we make the absolute value? All right, so look at this one right here. I have a y equal to absolute value of x plus 1. Okay, so how do I make an absolute value in here? One thing we know, if we have an absolute value of 1 is equal to 1, right? But if we have absolute value of negative 1, actually is also equal to 1. So that means everything come out from the absolute value must be positive. 0 absolute value will be still 0. Okay, so we can make this is kind of the absolute value is kind of like the V shape. All right, so if I graph y equal to absolute value of x, it will look at something like that. Okay, that's y equal to absolute value of x, because y always greater than or equal to 0. It won't be negative in here. All right, but we have a y equal to absolute value of x plus 1. So we move to the left, for 1 unit. Okay, all right, so we can look at this one right here. We can make a hue points, right? Same thing, we can make a hue point. So we have an x and y. Y is absolute value of x plus 1. So when x is 0, y will be absolute value of 0 plus 1, and that's 1. Okay? And when x equal to 1, y will be absolute value of 1 plus 1, and that is 2. When x equal to negative 1, y will be absolute value of negative 1 plus 1, and that is 0. All right, and then we can plug that in. So when x is 0, y is 1. So right here, right? So this is the first one right here. This one is y equal to absolute value of x. Okay, and then the second one right here, this is absolute value of x plus 1. All right, or we can get rid of this one right here if you want. Okay, we're gonna just graph this y equal to absolute value of x plus 1. When x is 1, y is 2. So when x is 1, y will be 2. Okay, y will be 2 right here. All right, so this is 1 and 2. And when x is negative 1, y will be 0. So notice right here. All right, and I also need to have another point when x equal to negative 2, y will be negative 2 plus 1, right? Negative 2 plus 1 will be negative 1, but the absolute value will be 1. So when x equal to negative 2, this one will be 1. All right, will be 1. So this will be negative 2 and 1. All right, and then you can connect all these points together, and that is a straight line in here. Okay, I can also show you how to graph this one in a calculator. Okay, sometimes people say, where do I find the absolute value in the calculator? Well, actually, you will have to go to math here, and then go to the number. Okay, and then you have absolute value, put it in here, and then you have an absolute value of x. The graph. Okay, so that's absolute value of x. And you go to the second graph, will be the table. Anything you want to exit the blue color, you have to hit the second first. Okay, anything you want to exit the green color here, you need to hit alpha. So let me just give you an example, right? If I hit 9, if I hit just 9, I will get a 9. If I hit second 9, I will get this blue one, W. And if you want to get this green one, I will have alpha 9. So I will get a Q in here. So you can see each button has 3 functions, right? And then you pair with second and alpha. Okay. All right. So I graph this one right here. So that's y equal to absolute value of x. Second graph, you can see all the table in here. Even when x is negative, y is always positive. Okay. The only thing y is 0 here is when x is 0. All right, so we're gonna graph another one right here. Is y equal to absolute value of x plus 1, right? So we have to find the absolute value from the math. Okay, and then the ABS is the absolute value. All right, so we have x plus 1. Okay, move cursor up and hit enter. And now you can see the red one is the blue one moving to the left for 1 unit in here. All right. And you can also, same thing, go to look at the table in here, right? So look at the table. All right. So that is Y1 and Y2. All right, so you can graph this one for all in the calculator if you have a graphing calculator, and we really recommend you to have a graphing calculator because it's helpful. Okay. All right, so the graphing utility here, usually you can make a x and y negative 10 to 10. That's the standard view, right? If you go to the zoom here, zoom to standard, zoom number 6 is standard. That's usually in the setting. If you want to customize you here, you can also customize this on your own, right? Go to the window if you want a negative 5. That's fine. And then if you want a maximum value of x is just 5, well, that's fine. Okay, so that's how your graph look like. All right, now you have x a little bit wider, y a little bit um, smaller. That's fine. You can customize your window any way you want, right? And I usually just go to zoom number 6, zoom standard. Okay, so that will automatically set up the window for you. All right, so now we talking about the x and y intercept, which I mentioned that a little bit earlier. The x-intercept is the graph passing the x-axis and y should be 0, right? The y-intercept here is the graph passing the y-axis and the x should be 0, okay? So look at this one right here. This point is called the y-intercept because the graph passing the y-axis, so x is 0, right? So that's 0 and 5. And this point is the x graph passing the x-axis. So x is negative 3, y is 0. So that's called the x-intercept. All right. We can find the x and y intercept, if we have a graphing, right? Like say, if I have a y equal to 3x plus 6, how do I find my x and y intercept? So if I want to find the x-intercept, I let y equal to 0 and then solve for x. So now I have a 0 equal to 3x plus 6 minus 6 on both sides. These cancel out. So we have a 3x equal to negative 6, right? Divided by 3. So x will be equal to negative 2. So negative 2 and 0, that's the x-intercept, right? If I want to find the y-intercept, I let x equal to 0. So let x equal to 0. So y will be 3 times 0 plus 6, which is 6. So we have a 0 and 6. That is your y-intercept. So if I make a graph in here, okay, so I have a x is 0, y is 6. So that's 1, 2, 3, 4, 5, 6 right here. All right. And then this one, negative 2. So negative 1, negative 2, y is 0. All right. So we have a 2 point right here. You connect these two. You connect these 2 points together. Okay, and that is y equal to 3x plus 6 grams. Okay, and that is your x and y intercept. All right, so if you want to find the x-intercept, you let y be 0. If you want to find the y-intercept, you let the other one, which is x equal to 0. All right, so that is our fourth section. We're going to introduce all these intercept in here and the graphing. Hopefully they're giving you a little bit of quick start for the section 1.1. Okay. We're gonna go ahead and look at the section 1.2. Again, if you have any question, always jump in to ask. All right. I don't mind you interrupt anytime at all. Okay, so this is linear equation and a rational function for the section 2. All right, so we're gonna need to be able to solve the linear equation, include in one variable, and then rational function include a denominator, which is called a fraction, right? And then be able to solve the real world question we call the application in here using the math modeling. Okay, so that is this one. I talked a little bit linear equation earlier when we do the graphing, right? So you have ax plus b equal to 0. That's the linear function because the power of x is only equal to 1. All right. This one, yeah, this is also power of x equal to 1, right? So how do I solve for x in here? Well, if you solve for x, that means we want to make sure we have just one x, right? We have want to solve for x. So in order to get rid of actual term on the left hand side, you have to get rid of this one right here, get rid of this guy, right? So how do you get rid of this guy? Well, you minus the 5, but you have to do that on both sides so you can keep balance. All right, you cannot do just one side, you have to do both sides on the equation so you can keep balance. The equal sign is kind of like the scale, it keep balance. Okay, so this will cancel out. And then 29 minus 5, you got 24, right? And then you divide by 4, the coefficient of the x, which is 4, this coefficient, right? You divide by 4 on both sides. Again, when you do something, always do the same thing, do the same thing. All right, do the same thing on both sides, okay? And then this will always maintain balance. All right, so 4 and 4 cancel out, and then with 24 divided by 4, so you got x equal to 6. And that is called a solution, okay? And how do you check if your answer is correct or not? You can pop it back to the original equation to see if that equal to right, okay? When you pop the x in equal to 6 in, you have a left-hand side equal to the right-hand side, so that means this is a check. That is the correct answer. All right. Okay, so that is how you solve this one right here. Now we got a little bit more challenging here is how do you solve this kind of, we call a fraction, okay? Yeah, I know even like people got to calculus, they still do not like fraction, right? But when you deal with math, you always have to deal with a fraction. So I would just say if you do not like it, get rid of them. Okay, so we do not like a fraction, so we can get rid of fraction. So how do you get rid of fraction? Well, you need to multiply, called LCD. Okay, LCD right here. You have to multiply the LCD in this case. Okay. All right. So the LCD here is the least common denominator. All right. So how much is the least common denominator? Look at this denominator here. We have a 4. This one did not, let me write. We have a 4, right? And then we also have a we also have a 14, and we also have a 7. So we usually look at the largest denominator. The largest denominator here is 14. Okay, the largest here denominator is 14. That this way will be a really quick and easy way to find the LCD. All right. So look at 14. Can 14 be divided by 7? The answer will be yes. 14 can be divided by 7, which is you got 2. So if I don't have this 4 right here, if I only have a 14 and 4, my LCD, for 14 and 7, the LCD will be 14. Okay, but the problem here is I have a 4 right here. I have another 4 right here, right? So if you look at 14 divided by 4, it's not an integer. It's not equal to the integer, not equal to integer, right? In here. So since 14 divided by 4 is not an integer, so that means 14 cannot be LCD for all these 3. Okay, And it would be easy to just double, okay? Since 14 is not a denominator, I can double 14. So double 14, which is 28. All right, so now you can see 28 can be divided by 4, right? 28 divided by 4, you got 7. 28 can be divided by 14, you got 2. 28 can be divided by 7, you got 4. So now this 28 can be divided by every one of the denominator, and you got LCD is 28. So that means if I multiply both sides by the LCD, all the denominator will be gone. Okay, but you have to multiply both sides by 28 in order to cancel them all. All right, and then you do that step by step in here. Okay, so you do that step by step. All right, so 28 divided by 4, right? This cancel out, so you got 7. So you 7 need to multiply the numerator. 28 divided by 14, you got 2. So 2 need to multiply the numerator. And then 28 divided by 7, you got 4. So 4 need to multiply the numerator. Keep the sign, keep the negative sign in here, right? And then the next step, you just get rid of denominator, get rid of parentheses, multiply it in, right? Distribute it in. So 7 times x, 7x, 7 times 3, 21, and then multiply it in, okay? After you multiply it in here, you will need to move x to one side, number to the other side, all right? So you're gonna add a 4x, on both sides, right? And then this will be canceled out. So this will be 3x minus 21 equal to negative 10. And then you have to get rid of this 21. So this is negative. So you're going to need to plus 21 on both sides, right? And then this cancel out. So we're going to have a 3x equal to 21 minus 10, which is 11. And then divided by both sides by 3. So x will be 11 over 3. All right. So that is your solution in here. Yeah, your answer can be a fraction, which is very possible. All right. Your answer cannot be always an integer. Okay. So that's how you solve this type of fraction. All right, and then of course, if you want to check your answer is correct or not, you can plug it in, right? You can plug it in, and then, but this will be a long check, okay? So, and then we also, when we solve a solution, we also need to make sure denominator cannot be 0. So our denominator here is all numbers, so yeah, it won't be 0, okay? So x equal to 11 over 3 is the correct answer, as long as you calculate right. All right, so that is how you do this one right here. Okay, I think we just solved this one earlier. Okay, so how do we solve this one right here? This one right here is called a rational function. So what is a rational function? You have a fraction. Anything with a fraction is a rational function, right? The problem here is we have a denominator with x. All right. So one thing here is we have to be very careful. Denominator cannot be 0. All right. Each denominator cannot be 0. Each denominator cannot be. Check the restriction on a variable by setting we call this is okay or not. If you have a 0 divided by 5, you got 0, right? So that's called okay. 0 divided by a number is okay. But if you have a 5 divided by 0, that's called no. N-O, no. All right. No here, that means undefined. Okay. So if you remember these two words, okay and no, will be really make it easier. All right. So when you have a no, it's undefined. All right. So that means when we solve this one, this whole thing here, we want to make sure denominator cannot be 0. So 2x cannot be 0. If you solve x cannot be 0. 3x equal to 0, x will be 0. So x cannot be 0, right? So the domain here, domain is the x value you can have. The domain here is x can be anything, but x cannot be 0. Okay? So that means if we go to solve this equation and then we have one answer, x is 0, we have to get rid of that. All right? Because the domain said domain is a king. All right? The king said x cannot be 0. Okay? All right. So if you look at this LCD here, right, we have x, so x need to be in LCD, right? And then we have 8, we have 18, we have 3, we have 2. You can see 18 can be divided by 2, you got 9, 18 can be divided by 3, you got 6. So 18 is the LCD for 2 and 3, all right? And the 18 is cell because 18 divided by 18 is 1, all right? So our LCD here will be 18x, okay? All right, so we can go to multiply both sides by 18x. Okay, multiply both sides by 18x. Okay, and then you can see this x cancel out, and then this cancel out. This will be 9. So 9 times 5, right? And then the first one, 18 cancel out. So you still have an x there. So this will be 17x. Okay, and then minus this x cancel out. So 18 divided by 3, you got 6, right? And then 9 times 5 is 45. Okay, so we get rid of this 6 term. Okay, and then we have a 17x equal to 51, right? And then you divide by both sides by 17. So you got x equal to 3. All right. And if we check the domain here, x is not 0, so x is 3. Okay, so 3 is good. 3 is a solution. All right, so 3 is a solution. We check the domain, x is not 0. So that is how you solve this called a rational function. Okay. One thing different here is rational function. You want to make sure denominator is not 0. All right. Okay, let's look at another one here is another rational function here. This one right here, you will need to do the factoring. Okay. I know this is college algebra, but sometimes people forget a factoring. If you forgot a factoring, I have a 2 short video which you can watch. All right. So we will talk a little bit as well. But basically, if you have a squared minus b squared, right, you can factor into a plus b times a minus b. Okay. 1 is a tricky one because 1 is equal. 1 squared is also equal to 1. So if you have an x squared minus 1, you can still be able to factor into x plus 1, x minus 1, right? And the same thing as x squared minus 16, you can see is x squared minus 4 squared. So you're going to factor into x plus 4 and x minus 4, okay? All right, so if you factor this one right here, now you can see the LCD here will be x plus 4, x minus 4, okay? Your LCD for this one, x plus 4, x minus 4, right? You multiply both sides by that, okay? And then the first one, you will have a x minus plus 4 cancel out. So you will still have a, let me go ahead and write down this one right here. Very cloudy in here. Okay, so the first factor cancel out. I still have a 1 times x minus 4, and then plus 1 is a minus 4 cancel out, so you still have a plus 4. Okay, and then this you factor into x plus 4, x minus 4, so all the denominator are gonna be canceled out, so this will be equal to 22, right? And 1 times anything still equal to 1, or still equal to itself, basically. So this will be just x minus 4 plus x plus 4 equal to 22. And you can see 4 and 4 cancel out. So I have a 2x equal to 22, right? Divide both sides by 2, you got x equal to 11. All right. Can we keep the 11 as a final answer? You have to check. This is a rational function. I have to make sure the denominator cannot be 0. So x plus 4 cannot be 0. So that means x cannot be equal to negative 4, right? And then you have a x plus 4 cannot be equal to 0. So x cannot be equal to 4. All right. And then this is x plus 4, x minus 4. So x cannot be equal either positive or negative 4. But my answer here, 11, is not equal to 4 or negative 4. So this one is good. It's a good solution. Okay. So that's how you solve for this kind of rational function. Sometimes you have to do a little bit of factoring. Okay. And then you also have to check the denominator for the rational function. All right, so that is probably the tricky part for the rational function in here. Okay. All right, so that is our 1.2. We skipped the 1.3, so that is, let's see, what is 1.4? Okay, 1.4 is about a complex number. Yes, in college algebra, we do learn a complex number, which is not a real number. Okay, what's a complex number? That is called an imaginary number. All right, since this doesn't exist in a real number system, so mathematicians call it is an imaginary number or complex number. So we're using the I as the first initial of the imaginary number. Okay, and then we define the I square equal to negative 1. You can see this one is not real because anything square usually is positive 1, right? But the imaginary number I square defined as negative 1. So if I take a square root on both sides, okay, square root of I square will be I. So I will be equal to square root of negative 1. Okay, so that is a definition in here. I is equal to square root of negative 1, and then the I square will be equal to negative 1. So that's called a imaginary number definition. All right. So this is called a standard format for the complex number because like we have a 2 minus 3i, right? So 2 is a, b here will be negative 3i. And the standard format is using a plus bi. All right. And this imaginary number, you can add and subtract just like a x value. You can add and subtract, you can multiply. Okay. That kind of thing. So let's see. Look at this one right here, right? So how do I add these two complex numbers together? Well, we call correcting the like term. Okay, the like terms. Okay, they look alike. We combine them together. So we combine the real number together. 5 plus 3, you got 8, right? And then you have a negative 2i plus 3i. You add a coefficient together, keep the i. So negative 2 plus 3, you got positive 1. So you don't have to write down 1. So that's 8 plus i. Okay, this one will be very similar, like you do the x correction, right? Like you have a 5 minus 2x plus 3 plus 3x. So you have a, 5 and 3 add up together, negative 2 plus x. So you have 8 plus x. So it's very, very similar to the variable calculation. The only thing difference here is if you have a multiply, right? And then you have 7i times this one, 7i times 2, you got 14i. 7i times negative 9i, you got negative 63i squared. We have to use I squared equal to negative 1. This definition, this is called a definition to simplify. Okay, so now you have a negative become positive. So that is 14i plus 63, or you write down the standard formula using a plus bi. So that is your standard formula here. Okay, so that's how you multiply the complex number. This one is called a FOIL, right? The FOIL in here. 2 items times 2 items, you're gonna get 4 items, and then you correct the like term together, simplify. Okay. If you do not like the FOIL in here, look at it. There's 5 times 6, right? And then 5 times negative 7i, and then 4i times 6, 4i times negative 7i. You got 4 items to begin with. If you do not like that, you can break down into 2 steps, right? Using the first number 5 times the second parenthesis. Okay, that is another way to do. You cannot break down 5 times the parenthesis, right? And then you have a 4i plus 4i, and then times the parenthesis. Okay, you can give yourself a little bit break, and then multiply each one in eventually. So you got the same answer. So you can write down directly like this one, or you can write down this one first and then come to this one. Okay, and then multiply them together. These two are the like term, right? So negative 35 plus 24, you got negative 11i. And then remember, I squared is negative 1. So you do need to simplify that. Okay, and then you multiply, you got a positive 28. So that is your final answer. All right, 58 minus 11i. Okay. We're gonna talk one of them, the complex number encountered here is called a conjugate. Okay, so what is a conjugate? If you have a plus bi, a minus bi is the conjugate. Okay, so what happens if you multiply the conjugate? Look at that. We have this formula we have earlier. If you have a plus b times a minus b, right? This is a squared minus b squared. So if I have this multiply, I will get a squared minus bi squared. Look at that. And then we have a squared minus b squared, I squared. And then we know I squared is equal to negative 1, right? So I will multiply by negative 1. This will eventually become all real number. I is gone. All real number. Okay. So look at that. Anytime if you multiply a conjugate, it will become a real number. So that is the conjugate. All right. Okay, so look at this one right here. I want to use the conjugate to divide by the complex number, and I want to write down this complex number into a plus bi form. A plus bi, called the standard form. Okay, so that means I want to get rid of I in the denominator. So what do? We need to multiply the conjugate. Okay, so 4 minus I conjugate will be 4 plus I. But you also have to multiply numerator at the same time. So this is called multiply by 1. Anything times 1 still equal to itself. Okay, so multiply the conjugate. All right, so you don't change the value, you just transform. And then we're going to have a denominator times denominator, right? So we're going to have a 4 squared minus I squared in here. These two cancel out, okay? And then that is negative 1. So we have a denominator becomes 17, right? Numerator, we don't have a formula, so we have to do the FOIL, okay? Y times 4, y times I, 4i times 4, 4i times I. And then these two are the like term, you combine them together. You simplify I squared equal to negative 1. So you have a 16 plus 2i, right? 21i. And then this is called a plus bi form. Okay, your a here is 16 over 7, your b here is 21 over 17, and then you have I in here. All right, so this is called rationalize the denominator. Sometimes we call rationalize the denominator. Sometimes we call write down into a standard form a plus bi. Okay. One thing here is if you have a square root of negative b, you will have to, like I said, square root of negative 2, right? You will have to write down this is square root of negative 1 times the square root of 2. And then using the definition for I in here, so this will be square root of 2i. Okay? Same thing as this one right here. If you have a square root of negative 121, you will have to break down square root of negative 1 equal to I, and then multiply square root of 121, which is 11i. Okay? If you have a negative square root of negative 9 times the square root of negative 16, you will need to break down each one. You will need to break down into a square root of negative 1 first. So that means each one need to have an I. And then this square root of 9 will be 3. This is another I. Square root of 16 is 4. So this will be 12i squared, or negative 12. So this whole thing multiplied together is equal to negative 12. It's not equal to positive 12. Some people say, can I have a negative times negative become positive? The answer would be no. Okay, anything, if you have a square root of negative, you always have to treat each one into an I. Treat each one into an I. All right. So that one is a common mistake if you don't do that. Okay. All right, so if you have an I power, you can simplify, right? We know like a I square, we know the I square equal to, we know the I square equal to negative 1, the I cube. I can simplify this one into I square times I. Okay, and I square equal to negative 1, so this will be negative I, right? So I cube is equal to negative I. If you have I to the 4, I can have I squared times I squared. And each I squared is negative 1. So this whole thing, I to the 4 will be 1. Okay? So if you have I to the 72 power, what happens? Well, you can look at the I to the 4 equal to 1, right? And then 4 times 18 will be 72. So this will be 1 to the 18 power. That is equal to 1. Or you can write down this one right here. You can have I squared times 36. And I squared is negative 1. Negative 1 to the even power is positive 1. All right, you can do this way as well. Okay. And I to the 65, which is the odd number, so you will need to break down the I to the 64 plus 1, right? So this will be I to the 64 times I. Okay. And then 64, you can have a 4 times 6. Okay. And that is I to the 4, 16i. So I to the 4 is 1. So this will be just equal to I. All right. So you can do the math, do the typical calculation with the I power. Okay. And that will be conclude into our section 1.4. Okay. And let's see what is on 1.5. 1.5 is about a quadratic. Okay, so this chapter 1 is kind of like include all kinds of different equations, right? And then we have a little bit more detail on each equation later on. So the first chapter, it seems kind of quite a lot. From like to the college algebra, but actually we are exploring a little bit more detail later on. Okay, so what is a quadratic equation? If you remember, the ax squared plus bx plus c equal to 0. This is a standard format for the quadratic. All right. We can solve the quadratic by factoring, by the square root method, and by the quadratic equation formula. Okay, so that is the standard format, as I mentioned earlier. The power of x equal to 2. Let's consider a quadratic equation. Okay. Zero product principle, that means if you have two number multiply equal to 0, one of them must be 0, right? Because if you have 1 times 4, it's not equal to 0. It's equal to 1 times 4 equal to 4, right? But if I have a 0 times 4, now I have a 0. So that means if you have a two product, multiply them is 0. One of them must be 0. Can be either A or B. All right. So that is called a zero product principle. Okay. So if we have a 2x squared plus x equal to 1, right? And we usually like to make it to the standard format. Okay, make sure the right hand side is 0. So we minus 1 on both sides, and that will be equal to 0. All right. And then we can do the factoring in here. So again, if you do not know how to do the factoring, I have a two very detailed video that you can watch. One is called a for your factoring method. One is called a grouping. All right, or sometimes called AC method. Either one would be good as long as you can factor. That is, any method is fun to me. Okay. 2x squared, we can only factor into 2x and x, right? If I do the FOIL factoring, FOIL, this is the first term. Okay, this is outer, inner, and then this is the last term. All right, so I factor my first term into 2x and x. And the last term is -1. The only thing I factor -1 is only one way, either 1 or -1. Okay, so I can -1, I can only factor into 1 and 1. All right. Which one is negative? I don't know. But I will need to make up the inner and the outer multiply, add up together has to be equal to the positive one. Okay. So if I go to look at this one, my inner multiply, this will be 1x. My outer multiply, this will be 2x. So 1x plus 2x here, I will need to have a positive x. So that means this must be negative. Okay, so negative 1x plus 2x, I will get a positive 1x. So that means this will be negative. This should be positive. All right, so look at this one right here. Now we have negative 1x, right? And then outer multiply, this is positive 2x. So these two add up together will equal to x. Okay, so that's the factoring method in here. All right, called a FOIL. And then we have a 2x minus 1 equal to 0, or x plus 1 equal to 0, right? And then we solve for each one. So x can be equal to -1, or we add a 1 on both sides. Okay, so we have a 2x equal to 1 divided by 2. So this x can be -1 or 1/2. Okay, and if you do not know if you do this one correct or not, you can plug it in, check the left equal to right. Okay, as long as your left hand side equal to right hand side, that means your answer is correct. All right, but this one checking is optional. You don't have to, because this domain here for the quadratic is all real number. Okay, this is how we write down all real number. All right, so that means as long as you figure out x here, as long as you calculate right, all numbers are acceptable. Okay, you can plug it in. Yeah, you can plug it in and then check the left equal to right. But as I said earlier, checking is optional. Okay. Another method to solve quadratic is called a square root property, right? So look at that. If I have an x squared equal to 4, how much is x? Well, I just have to take the square root on both sides. But remember, when you take the square root, you need to have a plus and minus, okay? So square root of x squared would be x. Square root of 4 would be 2, right? So look at it. If I plug a 2 square, I equal to 4. If I plug a negative 2 square, is also equal to 4. So that means the x can be either positive or negative 2 in here, okay? So this is called a square root property, all right? Okay, solving this equation in here, you have a 5x squared plus 45 equal to 0, right? So we need to isolate the x. So minus 45 on both sides. Okay, so this cancel out. So I have a 5x squared equal to negative 45, right? And then we need to divide by both sides by 5, okay? So 5 and 5 cancel out, and then 45 divided by 5 is negative 9, right? Now we're going to need to take a square root on both sides, okay? And remember, square root of negative 1 equal to I. So this one, you're going to need to write down square root of negative 1 times the square root of 9, right? And then that's I, that is 3. So we usually just write down 3I. All right, plus and minus, okay? So that means this solution is not a real number, it's called a complex solution, all right, or imaginary solution, which is quite possible in a quadratic. Excuse me. There's there's another method called completing the square method. That one is a little bit more complicated. So I'm going to skip that for now. Um, we usually can using the quadratic equation formula to solve. That would be much easier. And we will talk that method in a later chapter. So give yourself a little bit break that way. The quadratic equation formula, which you must write down in a standard form, okay? You must write down in a standard form in order to calculate. You have to write down in a standard form in order to use the formula. If it's not in a standard form, your ABC gonna be wrong and the formula won't be able to use. Okay, so that is very important. All right, so this one is already in a standard form because I have ABC, my right hand side is 0. Okay, so you can just write down your A, B, and C. So this is your standard form. So your A here is 2, your B here is also 2, your C here will be negative 1. All right. So you just match the ABC and then just plug it into the formula. So using the formula is the easiest. All right, as long as you write down your ABC correctly. Okay. Remember this negative is from the formula. All right, so you have to carry this negative in here. All right, and your B here, if your B happens to be a negative, you still have to carry this one, okay, because this is the formula. And then you just plug it in, right? So 2 times 2 is 4. This one you can get rid of for parentheses. okay? And then this will be 4, 2 squared will be 4, negative, negative become positive, right? So 2 times 4 times 2 will be 8, all right? And then we have a negative 2 plus and minus the square root of 12 over 2, right? And then this one, you can write down negative 2 over 4 plus square root of 12. You have to simplify. That's 4 times 3. And square root of 4 times the square root of 3. 3, you cannot take it out, but 4, you can take it out as 2. Okay? So this will be negative 1/2. Always simplify, right? And then this is 2 and 4 cancel out. So this is 3 over 2. So that is your final answer. Okay? Sometimes depends on the minded method. If you cannot write down the plus and minus, you will need to separate into 2 answers. Okay? This one or negative 1/2 minus square root of 3 over 2. Okay? So that is 2 solutions in here. So that's how you use this is how you use the formula, which is very straightforward, right? As long as you write down in a center form and then you plug it in correct, you must get the right answers. Okay, that's your final answer. All right, so the b squared minus 4ac, this one is inside the square root. We give it a name called a discriminant, right? If this is equal to 0, your answer here will be just negative b over 2a, right? Because if this whole thing is 0, plus minus 0 is the same thing. So if this is equal to 0, you only have one real solution, right? One real solution. If the b squared minus 4ac greater than 0, all right, so now you're going to have a two real solution, okay? And sometimes this can be negative, can be less than 0. If this is less than 0, you're going to have a two complex solution. All right. So yes, this can be less than 0, and then you're going to become a complex solution. All right. So that is indicate these 3 scenarios we just talked about. All right. So if you look at this one right here, right, compare the ax squared plus bx plus c equal to 0. Your a here will be 2, your b here will be negative 7, your c here will be negative 4, right? So if you calculate b squared minus 4ac equal to 81, so this is a positive number. So you're going to have a 2 real solution, okay? All right, so we encounter a little bit application in here. So this is the formula models woman's normal systolic blood pressure, right? PAHA. So use this formula to find the age to the nearest year of a woman whose normal systolic blood pressure is 115 mmHg. All right, so what do you do? Well, that is P is given. Okay, so P is 115. And then you want to solve for A. All right. So that is this one right here. And then this one we're gonna using the formula. So standard formula is ax squared plus bx plus c equal to 0, right? So I will have to minus 115 on both sides. Okay, make sure this is equal to 0. Okay, and then I minus 115, so this will be negative 8. All right. It doesn't matter. You have a 0 on the left or on the right. I can write down this 0 on the right hand side if you want to, right? I can make this whole thing equal to 0. Okay, so I can make this whole thing equal to 0. So your A here is 0.01. Your B here is 0.05. C here is negative 8, and then plug it into the formula. Okay, so you can just plug it into all these formula in here, and then you can do the calculate using the calculator to estimate this whole thing. All right, so you're gonna have a one positive, one negative, but we usually get rid of negative number because this is application. All right, application. The A here represents the age, so we are not going to the negative age. So we're gonna only put a positive one. Okay, so this indicate the woman is approximately 26 years old. Okay, so if I 115 is the normal one. All right. So that is the application, right? So a lot of time people say, I did the math, when I'm going to use that. So this kind of real question is just a little bit softer, the equation. Okay. All right, we skip the 1.6, so we're gonna look at the 1.7, which is the last section for this chapter. Okay. This section here is the linear inequality and the absolute value inequality. I know we cover quite a bit, but we are not quite get into the very deeper one, just pretty much on the surface. But our topic for this chapter is pretty different variety. Okay, so we need to know how to use the interval notation. Okay, so what is the interval notation in here? If you have x greater than 1, less than or equal to 2, you write down smaller number on the left, large number on the right. That is the interval notation. Okay, and then since x do not have 1 do not have an equal sign, so I'm going to write down into parentheses 2 into bracket because 2 has an equal sign, right? That's the math symbol in here with the equal sign. When you have an equal sign, you use bracket. All right. If you have an x greater than 1, less than 2, you're going to just use those parentheses, right? If you have x greater than equal to 1, less than equal to 2, now you use both bracket. Okay. Always a small number on the left, large number on the right. If you have x greater than 1 but don't have a right hand side, all right, so what does that mean? That means 1 and then right hand side gonna go into infinity. Infinity always using parentheses because you never ever equal to infinity, right? But if I have an x less than 2, okay, so if you drop a number less than 2, it's going to the left hand side. So 2 is the maximum number. All right, so your left hand side going to be negative infinity to 2. Okay, so the interval notation, you only have just these three types. X between two numbers, or x just greater than a number, or x just less than a number. Only these three different situations. Okay. When you have an equal sign, you use bracket. You don't have an equal sign, you use parentheses. So actually, it's pretty straightforward. All right. So open interval. Yeah, open interval. That means always using parentheses, right? And then this is called consider a closed interval. You using the bracket in here. All right. And in finite interval, okay, in finite interval, always use the parentheses on that side. Okay, this is greater than, this is less than or equal to. All right, because greater than, if you make a number 9, right? So this is go all the way to the right, and then this is all the way to the left. Okay, all the way to the left. All right, so this just giving you a little bit more example in here. Okay, so this represent x between -2 and 5, right? If you drop a graph, this will be the bracket, this will be the parenthesis, okay? That kind of thing. Intersection, if you have this one, that means you need to find a common part, okay? 1 to 3, common 2 and 6. The only thing that the intercept in here is between 2 and 3. Okay, that's called a common part. How do you solve the inequality? Basically, solve the linear inequality is very much similar to the equation. The only thing you have to be careful here is when you divide or multiply a negative number like this one right here, right? You have a 2 minus 3x less than or equal to 5. So we need to isolate x, okay? So you minus 2 on both sides. So now you have a negative 3x less than or equal to 3. But when you multiply or divide a negative number, you have to switch inequality direction. Okay, look at it. This is less than or equal to. Now you're going to become greater than or equal to, because the number you divide is a negative number. If I have this is positive number, I don't have to change anything. Okay, so let's see if we do this one. We have 3x less than or equal to 5 minus 2 is 3, right? And then we divide by both sides by 3. Since this number I divided by is positive number, so this I don't change inequality direction, so we still less than or equal to 1. Okay, but this one is different. This one, the number I divided by is a negative number. That's why you have to switch the inequality direction. All right, become x is greater than or equal to 1. Okay, and greater than or equal to 1 is going to the right hand side. All right. This is called a compound inequality. Okay, so compound inequality, we call this is the n. 2x plus 3 greater than or equal to 1 and also less than 11 at the same time. Okay, so in order to do this one, you just have to do this for all of them. You minus 3 in here, you also minus 3 on everywhere. Look at it. So I want to isolate the 2x, right? So that means I have to get rid of this 3. Okay, so I will have to minus 3 on all of them in here. And then this will be negative 2, this will be 8. And then you divide by 2 on all of them. The number you divide by 2 is a positive number. Okay, so you don't have to change the inequality direction. This negative is okay. It's just by itself. But the number you divide by is positive. The number you divide by is positive. Okay, so you don't have to switch the inequality direction. So simplify, you have x between negative 1 and 4. All right, so that is called a compound inequality. Okay, another one, the last topic here is the absolute value inequality. Okay, so what is the absolute value? If you have an absolute value of x less than 2, get rid of this absolute value, x will be between negative 2 and 2. So the way to understand here is kind of you live less than 2 miles away from campus, right? So can be either from east or west, but it's 2 miles. Okay, so negative 2 and 2. So that will be in here, less than 2 miles away from this campus. All right. But if you have an absolute value of x greater than 2, so how do you graph greater than 2? You live away from the campus more than 2 miles away. Okay, so this is 0, this is negative 2, this is 2. So more than 2 miles away will be from here to the right or from here to the left. Okay, so that's how you understand more than 2 miles. So if you get rid of absolute value, it's going to be x greater than 2, or x this side will be less than the negative 1. Okay, so this is all. Okay, this is considered all 2 inequality. So you have a more than, you're going to have a 2 inequality solution in here. Okay, so if you solve this one right here, if you put an x on the left-hand side, this actually is greater than, right? So how do you get rid of absolute value? The first one is the same without an absolute value, okay? The second one right here, you're going to switch it. This one is kind of like an opposite or opposite. switch the greater than into less than, switch the positive into negative, and then go to solve this one, each one by itself. All right. So solve this one should be pretty straightforward, right? You minus 6 on all of them. So negative 3x will be greater than 12. And remember, this time you divide by is a negative number, so you need to switch the inequality direction. All right. This one will be negative 3x less than negative 24. Again, the number you divide by is a negative number, so you're going to need to switch to the positive. So this solution will be x greater than 8, okay? Or x less than negative 4, all right? So less than negative 4 or greater than 8, all right? So how do you write down an interval? Negative infinity to negative 4, right? And then you're going to have an 8 to infinity. So that is your solution in here, okay? So that's how you solve this kind of compound inequality or the absolute value inequality. For this one, you have to break down into two inequality. All right. So that's how you break down into two inequality, and then you solve each one in here. That is your solution. All right, believe it or not, we have just covered the entire chapter 1, all the content we have. Okay, so hopefully you have a little bit of framework to see what you need to know in chapter 1. I know it is pretty much a lot for the 4th week, but that is the path we need to have for this course, right? We use 6 weeks time, gonna complete the 15 weeks content. So you will need to double amount for each week, okay? And then next week, when we come back, I'm going to give you a real question review. I will go through the review for each test question, okay, to see how you look like. And your test question will be very similar to our review, but of course the number will be different, okay? So that is all I have for today for the new lecture, okay? Anyone has any questions? I'm going to stop the recording.